Hey everybody, and welcome back to Pre-Calculus with Mr. Beck as we continue our journey through mathematics. Remember, anytime you have any math questions, I've got your back and you've got your back. Today we're going to be talking about an entirely new system of graphing. This new system of graphing is going to be based off of really kind of what we look at as vectors. If you remember from Despicable Me, where you had that character vector where he says, I am magnitude with direction. What a polar coordinate system does focus on is magnitude, which we're going to call radius, and we'll make these connections as we continue through this, and direction, the angle. What we're saying is how far out something is and in what direction that it's located, and that's the angle. So as we begin our discussion about polar coordinates and then polar systems, first say, well, what is it that we've really been working with so far? What we've been working with so far is something that we call the rectangular coordinate system. This rectangular coordinate system, you guys are very familiar with. It's everything you've been doing ever since you first started graphing, second grade, third grade, or whatever that was. You have an X variable, which is your independent variable. You have a Y variable, which is your dependent variable. And then we create this point that we say, okay, we go out X units, we go up Y units, and then we create that point that we call X comma Y. So that's our rectangular coordinate system in a nutshell. What we're doing with our polar coordinates is we're saying, okay, how far out is that point? So how far out is that point? That's a radius. And then we say, well, in what direction? And the way we treat that direction is what direction based off of the x-axis. Something we've been working with as we've continued our discussion from chapter 6, chapter 7, and even through chapter 8. Our rectangular system, which is very nice, where we have an x comma y. Polar system, we do have our radius and we have our angle, where that radius and that angle, we no longer say one is independent, one is dependent. We now have a new term for it that we call codependent, where the x and the y, the radius and the angle now depend on each other to create the new point. So a little bit more terminology that we need to discuss is, well, if we're going to say we no longer have the rectangular system, we now have the polar system. First, what was the origin? The origin is at location 0, 0 on the XY plane. That location is right here on my mini graph. That origin, now we are going to call the pole. And the reason why we call it the pole is because it's still going to be our center in the graph, but it's going to be the center of how everything is going to be, or where everything's located. Where from that center, we're going to go out a certain direction, say maybe over here. Or if we start at that center, we can go out a direction, maybe up here. And so that pole, it's kind of like, if you remember those tether balls, and maybe I'm dating myself, but a tether ball on the outdoor gym playground, where you had a ball connected to a pole based off of, or like with string, and then we have that string that goes around and around. So it's kind of like what's happening with our system here, where we're going to take this pole or we're going to take this pole and we're going to take it out in whatever direction that we want. So new terminology. We no longer call it the origin, we call it the pole. And well, we used to have what we called the x-axis. We no longer have the x-axis. Our x-axis is now going to be called the polar axis. And just another name for it. So our polar axis is specifically, it's our positive x-axis. Now, yes, it does continue over here, but at the same time, everything when we talk about polar and when we talked about trigonometry in general, it's based off of that 0 as the positive x-axis. And then we no longer have the y-axis, we have the theta equals pi over 2 axis, because if you look at what is that angle that gets created, let me go ahead and write it. This is the angle pi over 2. So now that y-axis in this direction is now our theta equals pi over 2 axis. So it still looks like the x-axis, it still looks like the y-axis, just new name for it. Now, one of the biggest differences is in a rectangular system, each point was originally unique. So if we had the coordinate, say 2, 3, which is right here on this graph, at 2, 3, if I want to say where is 2, 3, there's only one location for 2, 3. But now when it comes to a polar system, that one point now can be represented in many ways. And we're going to do a discussion. We're going to journey through that and say, well, how can we name something in different ways? So as we begin, I'm going to focus on this website right here. This is GeoGebra. GeoGebra is one of my favorite places to go. GeoGebra and Desmos are amazing tools. This link is going to take us to right here. The author of this GeoGebra, this GeoGebra link is Tim Brzezinski. You need to give him some credit where it's due, where this kind of shows us how we create our different points. So going back here, first of all, first problem, we have this polar coordinate that we say is 4, 5, pi over 6. So if you look here, I already have this set up as 4, 5, pi over 6. Now the way this works is if you type in pi divided by 6, it changes that to a decimal so that it can calculate that as a decimal. But the way that we create the point is, let's go ahead, slide it. We first look at, or at least one of the ways that we can create it is we can first look at and say, okay, where is the angle 5 pi over 6? So if you remember from trigonometry, 5 pi over 6 is right here. And then as we go 5 pi over 6, then that's where the radius kicks in. It says, okay, we're going to go out 1 unit, 2 units, 3 units, 4 units, and we're going to end up at that terminal spot. And we write it as the radius first and then the angle. So that 4, 5 pi over 6 is located right there. So again, one of the most common ways, one of the most common ways that we write it is we do go out the angle first, and then from that angle we say, okay, how far are we going out? There is another way that sometimes we look at it and say, okay, if we start off going out at a radius of 4, and then from our radius of 4, if we follow along that path until we get to 5 pi over 6, which is right here, we can get our angle, or we can get our point there too. So that's where we have sort of what we call codependent, where we don't have to do the angle first and then the radius. We could do the radius first and then the angle. Most people tend to do it this way, the way the graph is set up, where we start by saying, what is the angle, then go out whatever that unit is. So going back to what we have here, if I go to 5 pi over 6, and if I'm going to go to 5 pi over 6, I need to say, all right, 5 pi over 6 is located right here. So if we go 5 pi over 6, and then we go out 1, 2, 3, 4, this point right here is what we call 4, 5 pi over 6. Now, if you notice, I said, okay, this is our polar coordinate, this is our rectangular coordinate. This is the way that we can write that polar coordinate in the more common way that we're used to. Now, if you see over here on the calculator, I already have 2 times the square root of 3 written in there. The 2 times the square root of 3 does have the decimal of 3.464, 2. So if we go out, that really should be a negative. If we go negative 1, 2, 3, negative 3.4 is roughly right there. And if we go up 2 units, you'll notice that that rectangular point is going to be the same as that polar point. And we can see that over here right now, where if we have the coordinate, or if we have the polar point, -6, 5 pi over 4, -6, 5 pi over 4, this kind of begs the question, what does it mean to have a negative radius? If you remember, this is our radius. If our radius is -6, that negative actually tells us direction. And I'll show you where that's going to come about. In fact, let's go back to the GeoGebra app. So we have -6. Let's not spoil it. So if we go -6 as our radius, and our angle, if we say as 5 pi divided by 4, again, that's going to turn into a decimal. So we start by sliding out. We go and say, okay, what's the angle? 5 pi over 4 should take us into the third quadrant right there. Now, if you notice, we are no longer going in the 5 pi over 4 direction. We are going backwards. And that's what that negative on the radius means, that we are going backwards instead of forwards. So instead of going out in the positive direction of the radius, we are now going to go backwards in the negative direction of the radius. So what I like to show is, let's go ahead, take us out to 5 pi over 4, which is in that direction. But then from the pole, we're going to go backwards. 1, 2, really shouldn't make that solid. 3, 4, 5, 6 to create that point right there. Now, I don't know how many of you questioned. I mean, if you saw I made the mistake on the other part where the x coordinate should have been negative. Both the x and the y here are positive, and that's because this ends up in quadrant 1 because of the negative radius in quadrant 3. So we go to quadrant 3. Again, we go to quadrant 3, but then instead of going forward into quadrant 3, we're going to go backward into quadrant 1. And we end up with this point right here, which is -6, 5 pi over 4. Now, some of you are going, why would we do this, call it a negative radius, when what we could do is we could say, well, that looks like we are going in the pi over 4 direction, which is what quadrant 1 is, and we go out with a positive radius of 6. Well, this is what I meant when I said that points are no longer unique, that if I said either one of these 2 points in polar form, both are correct. So something nice about saying, having some flexibility to say, okay, maybe I'm going in the 5 pi over 4 direction, but walking backwards, or going in the pi over 4 direction, walking forwards. We're going to be walking in the same place. So our first set of problems that we're going to do is, first of all, I discussed how to plot them. We're going to go ahead and actually plot them, and then we want to rewrite them in different ways. One of the ways that we can rewrite them is like I showed up here. Sometimes if we have a negative radius, you want to say, what is our positive radius? And then instead of having an angle in, say, quadrant 3, we're going to take our angle into quadrant 1. So looking at this point, A, 4, 2 pi over 3. So if I start off by looking at 2 pi over 3, one of the things I'm going to do on this graph is, this is pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6. Let's go ahead and write all these out. 5 pi over 4. And then 4 pi over 3, 3 pi over 2, and then 5 pi over 3, continue around, 7 pi over 4. I realize you probably don't need all of these, but let's go ahead and write them anyway. 11 pi over 6, and then we have 0 and 2 pi together. So our point is 4, 2 pi over 3. So what this means, and I'm going to show this kind of with the highlighter, if I go in the 2 pi over 3 direction, I'm looking at going in that direction. And then I want to go out to a radius of 4. So if I kind of follow along with this radius of 4, point A should be right here. So I have a positive radius of 4 with an angle of 2 pi over 3. So how can I rewrite that? Well, if I look at the example that I did before, what happens if I want to say, let's look at that 5 pi over 3 direction. So if I look at that 5 pi over 3 direction, but instead of walking forward into the 5 pi over 3, we're going to walk backward into the 2 pi over 3. That would give us a negative radius of 4. So if we look halfway around the circle again, but instead of going forward, going backwards, we're going to end up in the same point. Yet another way we can write it, suppose we said, hey, I would like to have that positive radius just because I'm not too comfortable with the negative radius yet. So if I look at that positive radius and say, what happens if I don't want a positive angle? What happens if I want a negative angle? So if I ask, well, what is coterminal with 5 pi over 3, sorry, with 2 pi over 3, what's coterminal with 2 pi over 3, but instead of going in the forward direction, we go in the backward direction, that would be negative 4 pi over 3. So we could write it this way, and one of the benefits is, suppose I want to focus on a negative angle instead of a positive angle. Why would I want to do that? I really don't know. But my experience, it comes down to sometimes we want positive angles, sometimes we want negative angles. Sometimes we say we want to go forward, sometimes we want to say we go backwards. So this gives us flexibility that we could do more. Where if we're stuck in the Cartesian system where we say, okay, this X and this Y, we're there. Now there's some nice things about the simplicity of that. But again, with the polar, this gives us more options, more flexibility, and allows us to do a lot more cool things in the end. So that's our point A. Our point B has a coordinate -2, 5 pi over 4. So I'm going to start, and I'm going to change colors on this one. So I'm going to start by going out the angle 5 pi over 4, which is right here. And if I go a radius of -2, instead of moving forward in that direction, I'm going to go backwards to right here. Well, kind of like before, if I said I don't want to have a negative radius, I want to have a positive radius. So let's call that a positive radius of 2. And now our angle is pi over 4. What happens if I want to maintain that I have a negative radius, but instead of moving in the positive 5 pi over 4 direction to here, suppose I want a negative direction, that would be -3 pi over 4. Now, remember, I said this is an equivalent point. There are lots and lots, and in fact, there are an infinite number of ways that we can create any single one of these points. What happens if I said, okay, if I don't want an angle between 0 and 2 pi, but if I want the angle between 2 pi and 4 pi, well, then I could say -2. And if I add 2 pi onto that angle, then I can say 5 pi over 4 plus 8 pi over 4 is 13 pi over 4. This is also going to be an equivalent point. Let's continue on. -6, -3 pi over 2. Let me change colors one more time. Let's go purple this time. So if I go the angle -3 pi over 2, it's going to go backwards. I am right in this direction. And a positive or a negative radius of 6 is not there. It's actually going to be down here. So -3 pi over 2 points. Let me show you that with this. So this is the angle -3 pi over 2. But if I move in the backwards direction, I end up right here. So a convenient way of writing that is our traditional. This is 3 pi over 2 as an angle, but moving forward as a positive 6 units. Or instead of, let's maintain that we have a positive radius here. Positive radius is 6 with a negative angle, -pi over 2. I could have chosen a couple other points. I'm just coming up with whatever's going on in my head. So, last but not least, 5, -2 pi over 3 plus 2 pi k. What do I mean by this? -2 pi over 3 plus 2 pi k. Well, if you remember, k can be any integer. So with that integer, it's kind of like what I was representing right here, that instead of saying 5 pi over 4, let's add 2 pi into that. Well, let's add 2 pi, let's add 4 pi, let's add 6 pi. That's what that 2 pi over k represents. So let's look at what the original coordinate is. Let's ignore that plus 2 pi over k, or plus 2 pi k, because that just says you're going to end up at that exact same coterminal location. So 5, -2 pi over 3. Let me change colors one more time. Let's go red. So -2 pi over 3 will take me down here into that direction. So if you notice, that's a positive angle, 4 pi over 3. And then we go out a positive radius of 5. That would be right here. So that would be D. So another way to write it is with that positive angle of 4 pi over 3 with the positive radius. Or if I want to go backwards, that would be that pi over 3. So if I go backwards at that pi over 3, let's face that pi over 3 direction. But instead of going into that pi over 3 direction, we're going to go backwards, and that's where that negative radius kicks in. So hopefully this gives you a little bit of explanation. The first thing we're looking at is how do you plot points using polar coordinates. And so going from polar to, or going from our, or graphing our polar coordinates, hopefully this gives you enough information. And as we begin to do video 2, so in just a moment we're going to go to video 2, we're going to start actually doing the conversion from one coordinate system to the other. So signing off on video number 1.